Okay, good morning, student. Today we will start exercise 10.3 from chapter number 10. Okay, so question number 1 from exercise 10.3, draw different pairs of circles. How many points does each pair have in common? What is the maximum number of common points? So now the question is that we have to draw three different pair of the circle. Okay, and now after drawing these three pair, we have to say how many common points they have. So let the different pair of the circle are as follow. You can see in the figure. Okay, this is our first pair, this is second, this is third. So we have drawn three pair of the circle. Now you can see in figure 1 that these circles are far away from each other. They are not touching at any point. Means they have no point of contact. You can see it. They have no point of contact or they have no common point. Now in second way you can draw like this. Exactly when you draw two circles that touches each other only at one point. Okay, so that is they have one common point. And now you can see in the third figure, if you draw two circles like they are crossing each other, so this is the first common point and this is the second common point. So there are three ways to draw these circles. Okay, first you can see that in the first figure number of common point, I think it must not be named. A number of common point is 0. In the second it is 1 and in the third that is 2. So you will write the answer. What you will write? The maximum number of the common point is 2 when two circles intersect each other. Okay, and minimum number is 1 if they are intersecting, and if they are not intersecting the number will be 0. Okay, it is a very easy question. Now the next question, suppose you are given a circle. Suppose you are given a circle, give a construction to find its center. Okay, it means that if we have a circle, okay, and we don't know where is the center of the circle, okay, exactly where the center is located, we cannot assume it. Let us draw a circle and put the point. It may or may not be the center of the circle. Assumption may be wrong. So what we will do? First of all, we have to use the statements of the theorems. Okay, theorem says that the perpendicular line of the chord or the perpendicular line drawn from the midpoint of the chord or the perpendicular bisector of the chord, you can use any word. So the perpendicular bisector on the chord is always passes through the center. It never depends on the length of the chord. Whichever chord you use, either it is a diameter, the biggest chord, or either it is any chord inside the circle. Okay, so what we will do to solve this problem? First of all, we will draw any two arbitrary chord. Okay, it must not require to draw exactly given in the solution. Okay, you have to draw any arbitrary chord. Suppose we have drawn two chords in the figure of any measurement at, at any point. You can draw it at any point. I can also draw this chord and this chord. I can also draw this chord and this chord. You can use any chord, any two chords of any length. Okay. So now we have drawn two chords. First chord is AB and second chord is BC. Now if we are able to do the perpendicular bisector of this both chord, okay, if we are able to do the perpendicular bisector of the both chord and there is a common point between of that both perpendicular bisector, okay, so see what will exactly happen. This perpendicular bisector will passes through the center and this perpendicular bisector will also passes through the center. So in the both case it will pass through the center and there will be a common point of that both perpendicular bisector that will passes through the center. Now remember the construction that we have done in our previous classes. What we have done in our previous classes, if we have a line or a line segment AB, if you have a line segment AB and if we want to draw a perpendicular bisector, what we will do? We will take the measurement exactly as AB and then we will make one arc here, one arc here. This arc will be from point A, this arc will be from point B, and same arcs below the line segment and above the line segment. Okay, when we have drawn this both arcs, we will join them and you can see that will be the perpendicular bisector. It means it will be the perpendicular to the line segment and also it will divide the line segment into two equal parts. Okay, so that is known as perpendicular bisector. Is it clear? So now we will do the same method, okay, and we will find the center of the circle. Suppose we have a circular shape ring, okay, or a bangle, whatever we have. So what will be the center of that thing? Without measuring anything, only by using your rounder you can do it. So now we will understand these steps and clear that everything we have done in the construction. We should write or we must write the steps, because if the construction will ask in examination, okay, so 2 marks is for drawing and 2 marks is for steps. So total 4 marks will be provided to you if you have done both things, drawing of construction and writing the steps. Okay, now see, take 3 points A, B, C on the given circle. So if we have circle, we have to take 3 arbitrary points A, B and C. Then join AB and BC. Draw perpendicular bisector of PQ of AB and draw perpendicular bisector of RS of BC. Now we have not to explain how we are drawing the perpendicular bisector. That is not our main construction right now. Just what we have to do, just we have to write that we have drawn the perpendicular bisector of the circle. Okay, so these are the formalism of the step, and now what will happen? PQ and RS will intersect at point O, and now O will be the center of the circle. I think it is clear to everyone. Okay, this is a construction which is also in the previous year's board's exam. Okay, but the question is with small change. That question is I think a bangle. Take a bangle and find the center of that bangle. Okay, it was the question in the board exam. Now, if two circle, question number 3 from exercise 10.3, if two circles intersect at 2 points, if two circles intersect at 2 points, prove that center lie on the perpendicular bisector of the common chord. Okay, so now understand this question carefully. If we have two circles, if they intersect at 2 points and the center lie on the perpendicular bisector of the common chord. So if we draw two circles, suppose we are drawing two circles, one is like that and second is like that, and this is the common chord. So when you draw the perpendicular bisector to the chord, both center will be on that perpendicular bisector. Okay, you can see O and O dash in the figure. See, AB is the common chord of the both circle. Common chord means AB will be the chord of the circle O, center with O, and AB will be the chord of the circle with center O dash. Okay, then if you draw the perpendicular bisector, then it will pass through both. We know that, but we have to prove it. We know that it is the right thing, but we have to prove it. So now what we will do, let first of all give the name to everything. Two circles with center O and O dash intersect each other at A and B. Then AB is the common chord of two circles. Okay, OO dash is the line segment joining the center. Now let AB and O dash intersect each other at M, perpendicular bisector, and the chord will intersect at point M. You can clearly see in the figure. Okay, this is the point of the intersection, okay, which is colored as a red. It is a point of intersection of AB and OO dash. Now take two triangles OAO dash and OBO dash. OAO dash and OBO dash. Okay, this is upper triangle and this lower triangle. Take this both triangle and you will see OA equal to OB because it is a radius. O dash A is equal to O dash B because it is also a radius. And O dash is O dash, it is a common side. So by SSS criteria for the congruence, OAO dash is congruent to OBO dash. So angle A is equal to angle 1 is equal to angle 2 from the simplicity theorem or simplicity rule. So triangle AOM and BOM. Now we are taking another two triangle AOM and BOM. OA equal to OB, OM equal to OM, and angle 1 is angle 2. It is already proved. So by SAS rule, OAM is congruent to BOM, so angle 3 is equal to angle 4. Now angle 3 plus angle 4 is equal to 180, but they are equal. So the value of angle 3 and 4 is 90 degree, and it means that AM is perpendicular to OO dash, and AM is equal to BM from the reciprocity rule. So M will be the midpoint and it will be the perpendicular bisector, and as we know, if the M is the midpoint of AB, okay, both the center lie on the perpendicular bisector of common chord. So that's how we have proved it. Okay, we don't know if we are drawing that line it will be a perpendicular bisector or not. So what we have done, let us quickly revise it. We have proved these two triangles are congruent, and then another two triangle which is AOM and BOM. Okay, AOM and BOM, and that's why we can prove it. That is a perpendicular line, and perpendicular line will always passes through the center of the circle. The line which is perpendicular to the chord, the line which is perpendicular bisector of the chord. So both things we have to prove. First we have to prove it is a bisector, and second thing that we have to prove that is a perpendicular. If it satisfy the both condition, if it satisfy the both condition, we can definitely say that this is the line which will pass through the center of the circle, but the chord is common between the circle. The chord is common between the circle, so it will pass through the both circle, center of the both circle. Okay, so that's how we have proved it. Now let us go, okay, for exercise 10.4.